So we got 1.512 grams of combined copper COO and Cu2O
Oh, I like how you
reacting
write.
with excess hydrogen, and that's going to form 1.275 grams of metallic copper. And the question is, what's the mass percent? We want to know the mass percent of CuO and Cu2O in the original mixture.
Okay. You guys want to try it?
Let's work this out. Any suggestions about how we can get started
Come
here?
on, let me
Wait,
try
what
to
is
see
that
this.
saying below CuO? Mass?
The question is asking us, what's the mass percent of CuO and the mass percent of Cu2O in the original mixture? So these are supposed to be
What did you do
questions.
last time with the starting materials and then the two little thingies?
The two equations.
Yeah, it's gonna be
Yeah.
similar to that.
I just don't really get it.
So,
Wait, so did we leave it in grams?
No, we turned it into
So-
moles.
Okay,
so
that's what I thought. What's CU?
63.55.
63 point what?
555.
Thank you.
So it's 222.65.
I might not be doing it right now. I'm having a really hard time with this for some reason.
What do you, okay, you have the moles of each, right?
Yeah, so what should we define X and Y as?
X is CuO.
X is what about the CuO?
Oh, moles of
I think we're best off
CuO.
saying that X is the number of moles, not the number of grams. I think
Right.
usually we want to work with moles. So we could say that we have X moles of CuO and Y moles of Cu2O. So then what equation does that give us?
Is
the
it equal to-
starting, like is
Wouldn't it be?
equals 1.512 grams
Converted into moles.
converted to moles.
Which is 0.0067909 moles.
How did you get that?
Yeah,
What
we did
equation?
last time, startings and then.
That was a different problem. wasn't
Okay,
it?
well, I thought we were doing the same thing, I didn't know. That's why I'm making a mistake.
Don't be scared.
Yeah, well, in this case, we don't know that these are going to have equal coefficients here in this equation, or they're going to be using them at the same rate. So I don't think we want to try to use that fancy trick of combining the copper and the two types of copper into one thing. Instead, I would simply say we've got X moles of CuO, and we've got the Y moles of Cu2O, and that's going to add up to 1.512 grams total. So how can I convert this into grams? I think we're going to be better off if we do the two conversions separately here.
Okay.
So this conversion over here, how do we make this, convert this into grams?
Well, whatever CU plus.
Yeah, so I think you guys might have already calculated the molecular weights. I calculated the two molecular weights as 79.55, and the other molecular weight is 143.79.
Wait, so are we putting them back into grams?
We want to put these into grams because this number is in grams, and we want to get an
Okay,
equation.
that makes sense, that makes sense.
So we want, X and Y are defined in moles, but in order to relate them to the 1.512, we gotta convert those into grams.
Right.
Oh, why to be like a really small decimal, so I don't know if I did it right. I'll just wait.
Oh, yeah, how we didn't do it yet. Yeah.
I did it.
So here's my first equation. The first equation reduces to this.
Yeah, I got that.
I got that too.
Okay, and now we need a second equation.
So for the second equation, I did 1.275 grams Cu times 1 mole Cu over 63.55.
I'm sorry, I have to think about this for a second.
That's
Um,
okay, so, hold on.
Oh, so we just took the products. You took the 1.275 and turned it into moles, which is what I did.
Scared me.
Like how we got the 0.06 moles last time.
63
I know what you're talking about.
You feel me?
So the molecular weight of the copper is 63.55. So let's see, your equation for that was,
Yeah.
oh, so you actually converted that into moles.
Yeah.
But now is that gonna be bad?
Isn't that
'cause
what
we're
we did
doing
last
it?
time?
Yeah,
Yes.
but this time we're doing it in grams. I just realized.
We did that last time too. You asked the same thing last time.
Oh,
There's our pennant.
clearly I didn't get it.
These problems.
See, I don't ask, I just learn. Like, I apply it, I don't understand.
Well, we aren't all as special as you.
No, the thing I don't understand it, I just do it.
All right, so we were given that we produced 1.275 grams of
Yeah.
metallic copper. Well, we can use this conversion ratio to convert that into moles of
I did
metallic
that.
copper. So I ended up with I think you got that too, 0.02 moles of metallic copper?
Yes.
Okay, so we know we're producing 0.02 moles of metallic copper.
And then
So far, so good?
Yeah.
Yes.
Yes?
Yeah, I
Or
get
not?
that one,
Okay,
so
and then your
I-
equation is x, yeah, it looks good.
So it's
So-
just x plus y equals 0.02.
X plus 2y equals 102, because it's U2.
So let's see, we know that we started with x moles of copper oxide. So how many moles of copper atoms would that give us?
Makes sense.
That would give us x moles of copper atoms.
What?
We know that we started with x moles of copper of CuO, which would also correspond to x moles of copper
Oh,
atoms.
yeah. You're a little. Oh. A little bit.
Now we know we started with y moles of Cu2O,
But that's 2 moles of Cu.
2y moles of Cu2. Every 1 mole of Cu2O actually contains 2 moles of copper. So this would be 2y moles of copper atoms. So this is the one way this is more difficult than the previous problem. Otherwise, they're
Yeah.
very similar. So this would give us 2y moles of copper. I can just cancel out all the moles of copper here to make this simpler. So I've got x plus 2y. I think one thing that might be confusing you is that here we were mainly thinking in terms of grams, and in this equation we're mainly thinking in terms of moles, but there's no paradox there. There's no rule that says that every equation has to be in the same units. As long
Right.
as the units on the left are balanced the units on the right on a single equation.
Okay.
So this equation has moles on the left and moles on the right, and this equation had grams on the left and grams on the right. Both of those are perfectly fine.